Hello, good day everyone. This is Jason Straight with the Pass Cloud Virtual Group. Our presentation today is AI on the Edge with Jared Rhodes. Before we get going, I just have a couple announcements and then I'll hand things over. So the first is that this virtual group is sponsored by Microsoft Azure. Microsoft Azure supports this group and hopes to help people learn more about building data platforms in the cloud, which probably is a pretty good fit. Now, if you are not yet a member of this virtual group, you can become a member by just going out to cloud.pass.org, clicking on the login to subscribe, logging in if with your Pass account, and then subscribing to the group. Doing so will get you information on upcoming sessions. On the screen there, I've listed out 12 of the more recent upcoming sessions that we have for this group, but we've got sessions going all the way through the end of March already. So we've got plenty of content coming up and lots of opportunities to continue to learn about building up data platforms. That said, we're always looking for more speakers. I try to do 2 sessions per week. So there is a link out on the cloud.pass.org website where you can click on that and fill out a form and get onto our schedule. Alternatively, you can just email me at cloud@pass.org and I'll then get you on the schedule as well. This virtual group is part of a number of virtual groups that Pass helps to support. They cover lots of different areas such as global Spanish, global Chinese, so you can learn things in other languages, and then also different areas of technology like database administration or building out hybrid solutions. Throughout the session, if you have any questions, please type them in. Jared's got a few places where he's going to ask for questions, so any questions that you do type in will be answered throughout the session, and then also at the end if there are any additional questions. And with that, let's get started with AI on the Edge with Jared Rhodes.
All right. Once I get the
Yep,
there it goes.
Should have it now.
Screen share. All right. If you can't hear me, type it in the chat and I will be notified. Otherwise, I'm going to get started. So this is AI on the Edge. My name is Jared Rhodes. I'm an MVP for Microsoft Azure and Pluralsight author, and you can reach me at any of the places here if you have any questions.
Real quick, Jared, I'm on the designer for PowerPoint. Sorry.
Oh.
There you go.
All right, so all that stuff I just said, and here's the contact information I was referencing. So you can just reach out to me there. And I'll have this up on the final slide, should you want to take a picture or something. Okay, so what we're going to do in this talk is we're going to discuss edge computing at a high level. Then we're going to talk about Azure's IoT Edge, which is what I'm going to focus on in this talk, its components as it relates to storage technologies. Those components is what we'll talk about after we talk about IoT Edge. And then we'll talk about cognitive services as a high-level overview of how it's utilized by IoT Edge. And then we're going to combine the power and see what all of these things together can make. All right, so let's talk about edge computing. So the way Microsoft has been talking about edge computing for the past, I'd say 3 or 4 years, has been with the terms intelligent cloud and intelligent edge. So the intelligent cloud, I think we all know. It's been something that's been put in front of us for quite a while and heavily reinforced as to how we want to do a lot of modern software. The intelligent cloud is basically unlimited resources and compute capability as far as your wallet can take you, basically. The intelligent edge is the extension, the eventuality of the intelligent cloud, in that not everything is going to go into the cloud. There are going to be both scenarios and ideologies that keep everything from going into the cloud, and the intelligent edge could almost be called everything else. And it makes sense. If you think about the world from Microsoft's point of view, there is the intelligent cloud, and then there's everything else. And they have branded that the intelligent edge. So let's go over a few scenarios of where we would want to use the intelligent edge. Let's say we're in a scenario where latency could be an issue. So, and I have to apologize if I slow down. I'm on vacation. I'm presenting on a laptop, and so I got the GoToWebinar taken up. I'm having to look at it for my own slides. So let's say we have a latency issue where we're trying to send messages up to a server, but it can't reach the server, right? We have latency issues, it's too slow. So what we'd want to do instead is we just want to process those messages on the edge, on the device, or on the source that is creating those messages. That way, we're not, or for this talk, we'll just say instead of messages, that data. We don't want that data to have to be sent up to the cloud because, well, latency won't allow for it. So we're going to have to move our compute to the edge. Another scenario like latency is bandwidth. Let's take a scenario where, and this is one I've actually encountered numerous times. Let's say I've got, let's just say a warehouse. And in that warehouse, we have a bunch of camera systems. We cannot stream all of that camera data to the cloud. It is usually impossible. An actual scenario I dealt with was traffic light cameras. So there was in Florida a scandal where the municipality that had the traffic light cameras installed so that if you ran a red light, you got a ticket, was involved for a pay-to-play scheme where they got paid by the number of tickets that were handed out. So what happened was all these cameras were installed, a scandal breaks out, and now none of the cameras are in use anymore, at least not for the red light issue. So a company was using those cameras to process intersection data, image data, or I guess video data. And they were using that video data to come up with traffic analytics. One of the problems we encountered was there was so much data coming from those cameras. Not only could we not send that data to the cloud, we actually couldn't even send all of that data to the Department of Transportation at data centers. So what we ended up doing was we had to process it on the edge. So these cameras actually had to process the images or the video feed as they created it. Another scenario is pretty simple. It's offline support. If I want to send messages, but I just can't. I can't even reach the server. I have to have some sort of storage mechanism and compute mechanism to process the data locally because I can't actually reach the cloud. Another scenario I've encountered with this was in oil and gas. They do not pump oil and gas near towers or near communication lines. They have some old stuff in the middle of nowhere, and you actually have no communication readily available. One of the ways they solve it is, to be honest, they drive trucks around with radio antennas on top of them to take readings sometimes. So we have to have this offline support to both save data and process data and make those decisions because it's not online, but for a few minutes every day. So we run it on the edge. Connectivity could be an issue. Back to the oil and gas scenario. There are tons of oil and gas and other industrial installments where the equipment predates myself. It was built sometimes 40 to 50 years ago, and the technology is not internet capable. So you would have an edge scenario where you have an entire network, let's say Modbus, and you would use that Modbus network connected to an edge device, and now you can have a transparent push so that that Modbus network can have both edge capability and connect to the cloud. There is the concerns about resource utilization. So I talked earlier and I said there were two reasons. One were physical limitations. Another reason you might want to use the edge is for resource utilization. So let's talk about it in the terms of AI. Let's say that we're doing something simple. We created a logo recognition system using some machine learning models, just some basic image recognition. Well, I could have it to where every time that picture is taken, we send that up to the cloud and the cloud processes that data. Instead, what I could do is I could train the model in the cloud, and then run that model on my application on the device. And now we can look at as many images as our individual customers want to who use our app, instead of trying to have the cloud resources available to process all of this data for all of our customers. We'll just use what they already have. And then finally, there's concerns for IP security. So in IP security, maybe I don't want the cloud to send maybe I don't want my IP to live in the cloud. What I can do is I can actually use the edge in coordination with the cloud, and I'll play that animation again. So we have the message sent to our edge device saying, go to our repositories, our container registries, grab the newest information or the newest app, pull it down, and run that model or that app locally. So all we did with the public cloud was we used it as a coordinator to say when something should know to update. But the public cloud never had our IP on it. We actually hosted our IP endpoints elsewhere. So in this case, I'm thinking a container registry or a model endpoint so that the model can be downloaded securely. So that way, the edge device is all that has our IP, and the cloud never touches it. Okay, so I'll pause here to take questions about the scenarios for edge computing.
All right, at the moment, Jared, we don't have any questions.
All right, then I'll keep going.
All right.
So now let's discuss Azure's IoT Edge. Azure's IoT Edge can be broken up into two major concepts, two major components. Oh, so I have to apologize. I don't remember these slides all that well. So the major concepts we're going to cover for Azure's IoT Edge are the Azure's IoT Edge runtime. We'll also discuss the IoT Edge modules. And then finally, we'll talk about the cloud-based interface to use to interact with our edge devices. So an IoT Edge module are the smallest units of computation managed by IoT Edge. And they can contain Azure services like Stream Analytics or our own solution-specific code. So there are two mandatory out-of-the-box modules required for Azure's IoT Edge. There is the Edge Hub and the Edge Agent. The Edge Hub is the message system. I want to call it the message brokering system, but it's the messaging system inside of our edge device. It's a local IoT hub proxy. It supports MQTT or AMQP, not HTTP. And I know this is more of the communications portion of this and not the data portion. We're going to get to that. But I do want to cover this part because Edge Hub is sort of a toned down versions of IoT Hub. So I'd like to list what exactly it does that's different. Most importantly, it handles the authentication of the modules that are going to communicate on your Edge, Azure IoT Edge solution. It optimizes connections. So for authentication, it's going to look and it's going to see if that module is authorized by IoT Hub to communicate across this bus on this edge device. It caches that so that it doesn't constantly have to go up to IoT Hub to check. And then finally, it optimizes connections. So if we have 10 different modules all streaming out to IoT Hub, the Edge Hub will take that and condense it down to one connection, showcasing multiple different internal connections so that it's optimized, but internally you don't see the difference. And it also has automatic offline message storage. If a message cannot be sent to the upstream for Edge Hub, it actually just keeps putting messages on the file system until it runs out of space. And it facilitates the module-to-module communication. And we're going to discuss what that means later on in this presentation. So let's say that I want to send a message. This is as easy as it is. This is actually from the template that is created when you go to Visual Studio, do new Edge container. If I want to make a custom processor, this is what it creates for me. So it automatically sets up the transport settings. we just say client open, and then whenever we want to send an event, we just say the event name and then the message that we would like to send. And then if we would like to respond to messages, this is the same thing in C#. We're going to say what input we are receiving, what we would like to process it, and what context we would like to have on that message. Whenever we run the Edge Hub module, we're going to set up routes. And so routes are basically how we're setting up. If you looked earlier where I said we're saying the output name and the input name, we're not actually worried about how that's wired up. Later, when we route, now we're going to say what message input goes to where, or goes into what output. And then we can filter those messages as we please. Okay, so that's the Edge Hub. That's how modules communicate, and also how Azure IoT Edge communicates up to Azure. The Edge agent is in charge of managing everything, specifically the modules. So it instantiates modules, it ensures they're running, it reports their status, it handles the manifest, which we'll cover in a second. And that's it. The Edge agent is basically the container that is running Azure IoT Edge, and the Edge Hub is the agent, is the module that is communicating between the other modules. So this is a manifest, and again, all the manifest really does is show the module content. And there's going to be two required modules. That's the Edge agent and the Edge Hub. So in the Edge agent desired properties, you're going to have the URIs of all your modules and the container registry credentials. For the Edge Hub, you're going to have your routing information and other desired properties. And then you're going to add in your custom modules that you're adding in and their desired properties. So for all of this, this is not normally managed manually. This manifest is going to be generated through either using the UI, PowerShell, or some other interaction with Azure's IoT Hub to generate the different configurations for these modules, or for the manifest showing how you want these modules to be configured on your Edge device. Okay, so I told you about the Edge Hub and the Edge agent. Now let's do a quick little visual of what's actually happening. Let's say I have a device, we'll say a temperature sensor. And that temperature sensor is generating readings. And so what the temperature sensor does is, as I showed in that earlier slide, it just says send message. So when it does, the message goes, it hits the Edge Hub, that is sent up to some other processing module if we'd want, and then we can send it up to the cloud. Let's say we have a more complicated example. I forget what my example is. I think it's facial recognition. Let's say now instead of temperature sensor, we have a camera. And what we want to do is a little more complicated. We don't want to store all frames from this camera. All we want to do is store the times that the camera thought it saw a face. So we're going to have our camera. Our camera is going to generate a message. It's going to go to the bus or the hub. Once it's in the hub, we've set up the routes so that it will go to our image recognition software. So we send it up, it goes to the image recognition and some storage apparently. And then it sees that there's a face, and we take that face and we send the actual image that was processed into a facial recognition up to the cloud. So let me go back. Again, the camera creates the image, and in this case, I told my story a little wrong. We're going to save the images locally, but we don't want to stream all of the images up to the cloud unless it's a face. So we send it, we send the message to two separate modules, one for storage and one for processing. The one that processing saw a face, so it sends that up to Azure, and now on the Azure side, we can set up alerts or additional processing as we would like. So whenever I'm setting up these modules, it's actually a pretty simple setup for how the Edge agent is deploying the manifest and keeping everything updated. So I've decided I'm going to make some changes. So I create my module for, let's say, the image processor, and I've updated it with a new model. So what I do is I go and I create this new model. I create a container wrapping this new module that can work with Azure's IoT Edge. I put that container in a container registry. Then my Edge device, or excuse me, I put that container in the container registry, and then I update my manifest. So what I do is I go in, let's say it's through the Azure portal, and I say, I want to add this, I want to update my module. I've got a new container for it, and I update my manifest. Okay, so that goes into my Azure IoT Edge, or my Azure IoT Hub. And then IoT Hub is actually going to manage the communication between each individual Edge device's Edge Hub and the cloud to tell it, hey guys, we've got a new manifest. So each go up, look, and pull down the new manifest. Now they see that there is a new container with a new model in it. So they go up and they pull the container down from the container registry. And then now each one will use that new module in place of the old one. So now we've updated our model in all of our Edge devices for image processing. You can use plenty of tools to do this. You can use Visual Studio Code, Azure Portal, the Azure CLI, Azure DevOps, the Azure IoT Hub REST API, and the IoT Edge plugin for Jenkins. So you can do this in numerous ways to update that manifest and push all those changes out to all those different devices. Do we have any questions now?
No, the only questions come in so far is asking about the recording, which will be available afterwards.
All right. Okay, so we said then we would move on to the Edge components. And the Edge components are, I don't like to use the term out of the box because we all work in, IT, and nothing is actually out of the box. But these are the components that have functionality that we can configure instead of having to write it all ourselves. I'll say it like that. So I broke the different components into 4 types. There is a 5th type that I'm not really going to show, and I'll just call that third party. And I don't know how much you guys care about the third party components, but they're there if you want to go look them up. But we're going to skip them for this talk. So I broke them up into, there's the messaging components, the adapters, the storage components, and then the AI components. So let's try to look at each. For messaging, I took out a bunch of slides because I knew this was going to be more of a data talk. But I'll still keep in the slide for what is in messaging. Really, you've got the Azure Event Grid on IoT Edge. So you can use Event Grid features on IoT Edge. So when we get to the storage part, there are components for storage that actually have Event Grid events. So we can create an Azure-like solution right on our Edge device. And then we have the IoT Edge API proxy. This is for exposing out across multiple containers, the APIs, but it's not very important right now. Okay. The adapters are also not very important to this talk, but I still need to list them. We're talking about, in the case of Edge, a high chance of having hardware, like I talked about in the oil and gas scenarios. So you can have, let's say, OPC twins and producers. That's a Microsoft provided component. Modbus adapters so that we can talk to Modbus networks, and serial ports. Just all these available to use as containers on your Edge platform. Now let's get into what you're probably here for, and that's storage. I think we have 3 types of storage. We have the Azure Blob Storage on IoT Edge, the Azure SQL Edge, and then SQL Server Module. So the Azure Blob Storage on IoT Edge is a provider for block blob and append blob storage solutions at the edge. So what does this mean? Well, Azure Blob Storage on IoT Edge allows for local storage, or is used for local storage in cases of limited connectivity, low latency, and reduced bandwidth. So Azure Blob Storage on IoT Edge actually tries to mimic a large API surface of blob storage. But one of the differences is what it's meant for on Edge versus what it's meant for in the cloud. So in the cloud, we're thinking sometimes long-term cold storage, big data, that kind of stuff. And that's not exactly what blob storage on IoT Edge is meant for. What we want blob storage on IoT Edge for is the immediate processing without having to send it to the cloud, and for local storage. So what are the two key features we want if we're going to use it for these items, knowing that later we may be sending it to the cloud? Well, we're going to want a cloud upload feature. And what blob storage on IoT Edge does is it can actually sync with a blob storage account in Azure. So what you do is you go in, and for this feature, you either turn it on or off for your blob storage on IoT Edge. You determine if you want the newest blob to be uploaded first or the oldest blob to be uploaded first. You then specify the account target, so your blob storage account target, and then you decide which source container, so the container on blob storage on IoT Edge, and the target container on Azure's blob storage. You choose if you want to delete after it's been completed, and then you do a full blob upload and block level upload. Let me make sure that's the last bullet point. Okay, so this is a wonderful feature. So what you do is you use Azure's blob storage on IoT Edge as you would in another, I would think, serverless or message processing style blob storage in Azure. So what we can do is we can set up multiple different containers on Edge. Let's take the example we used earlier of the image processing container. If we have one where we want to take all of the images that resulted in a facial recognition classification, we can actually just put all those relevant images into a specific container, turn on automatic cloud upload, and then have all of these images automatically uploaded to Azure Blob Storage whenever there is connectivity available for our Edge device. Now, the other feature we're going to want, oh, and just to note, this is, I don't know, I'll call it well-built, resilient. It can actually handle intermittent connectivity during these uploads. It does it through a pins, or what is it called? Whatever it does, the small block pieces that'll actually do a full blob upload with blob storage. So it handles that. If there's intermittent connectivity, it actually is well built enough so that it's resilient. So that if it gets disconnected halfway through, it knows how to reconnect. It doesn't re-upload the whole blob. It only re-uploads what it needs to, and all those other fancy features that you would need in a blob synchronization feature. Okay, the other thing we would need is auto delete. And auto delete's pretty simple. You either turn it on or off. You specify how long, what's my time to live for these blobs, and then you determine you're going to choose whether you want to retain it while uploading. That's pretty much it for auto delete. So for the Azure Blob Storage on IoT Edge module, you can go ahead and set up cloud upload and auto delete, managing a lot of what you would do for your blob storage on each individual device. Okay, I'm actually going to pause again, just a little out of order, in case there's any questions on Azure Blob Storage for IoT Edge.
Oops, sorry about that. No, there's not. No questions quite yet.
All right. Okay. So since we have no questions there, we'll move straight on to Azure SQL Edge. So Azure SQL Edge is, and I'm giving you the Microsoft definition, so if it feels like it's really fluffy, it probably is. So it's an optimized relational database engine geared for IoT and IoT Edge deployments. Azure SQL Edge provides capabilities to stream, process, and analyze relational and non-relational, such as JSON, graph, and time series data. Okay, so we said there were two. Remember, there was Azure SQL Edge, and then there was SQL Server Module. SQL Server Module is containerized SQL Server. Pretty straightforward. In fact, if you look at the documentation around the demos or tutorials, excuse me, for SQL Server Module, they even state this could be any containerized relational data store. You could do that. They specifically cite MySQL and Postgres. So in their tutorials, they're just saying this is just a containerized SQL server. Okay, so these are our two options. Why would I choose one over the other? So for both, we're using the latest versions of the SQL Server database engine. So for Azure SQL Edge and SQL Server module, they're both using the latest versions, or they are capable to. They both support SQL Server Management Studio. They actually support the Azure portal and a few other ways that you would want to access SQL Server. Azure SQL Edge has ARM platform support, and SQL Server does not. So there's no ARM platform support. So in the case that your client decides that they want to deploy their Edge solution to, let's say, Raspberry Pis, you can only use Azure SQL Edge. There would be no container module for SQL Server. Azure SQL Edge has additional streaming capabilities for real-time analytics and complex event processing, which we'll go over in a few slides. SQL Server module does not, to my knowledge. I always feel weird saying that to a group of people who know a lot more about SQL Server than I do. But to my knowledge, according to the documentation, there is no streaming capabilities like there is for Azure SQL Edge. Azure SQL Edge has built-in machine learning and analytics capabilities by integrating the ONNX open format. I think SQL Server probably has ONNX support through its Python, but I'm just giving you guys the documentation. So if 3 questions has popped up now correcting me, I'll take it to heart. But this is from the documentation. And then what does Azure SQL Edge not have? Well, little things like in-memory OLTP, related DDL commands, transact SQL functions, catalog views, dynamic management views. In fact, I kept open Chrome just to show what all is not in Azure SQL Edge, because I can't fit it into a slide. So if you go and you look at Azure SQL Edge's features, they do have the unsupported features, telling you what SQL Server 2019 on Linux has that aren't in Azure SQL Edge. To save us time, I won't go over all of these because they're not exactly, it's not like a few things, right? No distributed replay, no master data services, no stream insight, no analysis server, no Active Directory, no SQL Server browser, always on, not there, no managed backups, none of these subsystems, PowerShell, QReader, SSIS, SSAS, and SSRS, no CLR, no resource governor, no Active Directory again. You get the idea. So I went through and I kind of showed you what we had in Azure SQL Edge that we didn't have in SQL Server. But SQL Server has a lot of stuff that if you're building a complete data solution, Azure SQL Edge doesn't have. And to be honest, for most Edge solutions, what I didn't do in this talk was really go over the different sort of tiers in Edge. And what we're talking about here is either device or gateway level Edge solutions. There are data center level solutions, which would require SQL Server. In our case, since we're using Azure IoT Edge, we can think of it more as device or gateway level, which we will most likely not need all of the features that you would need in a complete data solution. What we need is a database engine geared towards processing real-time or time event data. Sorry. All right. Just thought I'd show all that. Okay, so in Azure SQL Edge, so there are actually stream processing modules outside of Azure SQL Edge. So what I'm talking about now is in the feature set of Azure SQL Edge, there is streaming support. Sorry, I've got to move the GoToWebinar control panel. All right, so the first step in streaming support for Azure SQL Edge is creating the stream objects. So what we're going to do is we're going to create the external file. There's actually a couple of different ways to create the stream object, and what I'm doing now is showing you the external file version. So we're going to say we're going to have an external file of type JSON, and it's going to be coming in from the Edge Hub. So we're going to give it the fully qualified URI for the Edge Hub input for that file that we're expecting. And then we're going to say we're going to create external stream. In this case, we're just going to call it my temperature sensors. And we're going to say the data source is that Edge Hub input that I just created. The file format is that input file. And I'm going to say I want the input or the location of it to be temperature sensors. Okay, and with no input or output options. Now this is going to create a stream that I can now run a query against in Azure SQL Edge. So what do we do next? We create the job and the queries. All right, so let's say that we're creating this streaming job. So what we're going to do in our query is write, we're going to execute sp create streaming job. We're going to give it a name, and let's just call it streaming job 2, and then we're going to give it our statement. So let's assume that we have all these different inputs and outputs created. We can select into these different output streams. And if we want to get even more complicated, there are special functions in Azure IoT Edge available to us, like anomaly detection change point, that we can run to create more complicated stream processing queries. In this case, what we're looking for is we are trying to look at over 20 minutes. Are we having any anomalies come up? And if we do, let's put those into an output stream called temperature anomalies, which we can then use later by a different module. Let's say we just want to send that to the cloud that we've detected a temperature anomaly. We can do that using these stream queries provided by Azure SQL Edge. Once we create the jobs, then we just manage the jobs, right? There's start streaming job, stop streaming job, drop streaming job, and other management functions that we can call by just naming the streaming job that we created. Okay, I'm going to take a pause there. Is there any questions about the streaming support by Azure SQL Edge?
There's a few that have come in. So this one came in right after the last section, asking if that was mainly for files.
No, I don't believe it's mainly for files. You can have other data sources. I'd have to go look at the documentation because I haven't done streaming with Azure SQL Edge, but there are other data sources, other data sources you can create streams with. I think you can do it even at the table level, but I'd have to look.
Okay. And then with the SQL Server module, is that a fully blown SQL Server instance, or is it just in a container?
That feels like a loaded question. It is just in a container. It is full blown as to what can be limited to a container deployment. Is that a good answer?
That's a good answer. And then regarding the ARM support, are you aware of if there will be any support for that in the SQL Server module in the future?
Not that I can speak to. I don't know if they've got plans for that.
Okay. And then the last question on this section is CLR fully missing from SQL Edge?
Ooh, I think so, but I'm not 100% sure. That is a good question. I haven't had a reason to look at CLR in SQL Edge. So to whoever asked that question, can you give me a follow-up on what your use case is? And then when we get through ONNX support, I'll see if I can't answer that.
Yeah, excellent. Those are the questions that we had. So
what I would like to do actually, we'll take a break and we'll look at that CLR support. So it says that it does not have CLR assemblies and related DDL commands and transact SQL functions, catalog views, and dynamic management views. Also, no CLR dependent functions, no CLR dependent datetime catalogs. So I haven't done enough CLR in SQL Server to know what's left, but it sounds very limited, if not completely missing. But not being the SQL Server expert, I'm gonna not give you the wrong answer.
all right, cool. And then one more follow-up question on there is, does SQL Edge support any other general purpose programming language like Python?
It does seem to support Python. That's what we'll get into right now. So thank you for the segue.
Excellent.
So yes, it does support Python. You can, I believe it supports Python because it has ONNX supported frameworks. You can use PyTorch, TensorFlow, Keras, scikit-learn, and CoreML. And let's actually, I'm going to cheat, so bear with me. I have not had enough time with SQL Edge because you can deploy models outside of SQL Edge, I've never done it within. So I can't speak to that as well. However, it does allow you to use Python packages. Azure Data Studio, deploy. So I do believe that you deploy the Python to it. So that would mean that you have Python available to you within SQL Edge. I believe so. So sorry to get off topic, but I'm pretty sure that you can. All right. I skipped over a lot for the ONNX model, and the reason I did was I didn't want to. I don't know. I didn't want to really mess up talking about how it's using the ONNX model within SQL Edge, just because I don't have any real experience with it. So my apologies if that's what you came here for. They do have an excellent deploying ONNX models on SQL Edge in the documentation, where you can look at exactly what they're doing. A lot of it seems to be massaging it so that they can train the model. In fact, everything up to this point is just training the model and deploying it. And then within SQL, you can use predict on the uploaded ONNX model. So right here, we're using the predict input and calling predict from the model. So I hope that covers it well, and hopefully one day I'll have a little more experience with it. The other thing you can do that I should note as we move on, if you do have an ONNX model and you do not need to use the Azure SQL Edge predict, you can deploy your model in a container as you please, host it however you want. And that's how I've done it with my previous projects. So we train our model, let's say it was a Keras image detection model, then we just take that Python and that model, capture it in a container, and now that lists or that communicates across the Azure IoT Edge hub, and we process it that way. Okay, so let's talk about the AI capabilities. I put Stream Analytics on IoT Edge in the AI capabilities because I didn't know where else to put it. It wasn't messaging and it wasn't storage, it's just stream processing. So it lives here.
Sorry to interrupt, you're on the design view again.
All right. So yeah, so that's why it's here. So we'll talk about it a little bit, although it's not AI at all, but I know where else to put it. And then we'll talk about cognitive services as AI, because everything else that would fall under the machine learning category, the artificial intelligence category, is pretty much just creating your own containers, and I don't think there's much to go over that in this talk. Okay, so let's talk about Stream Analytics. You can just create these routes for Stream Analytics. If you go to the portal and you want to create a Stream Analytics job, it actually has a specific drop down for you to say, I want to create it for the Edge. And you would specify your inputs and outputs there. And then you would, in your route, specify how those inputs are coming in and how those outputs are routed out. So for those of you that know that Stream Analytics, IoT Edge has pretty much everything that Stream Analytics for IoT Edge has pretty much everything that Stream Analytics has as far as language features go. And it's pretty simple to use, right? It's still primarily focused to streaming data, timestamp streaming data, or event source data. So you can just select time, and you have a ton of different language features available and functions for like windowing, so that you can do these time-based queries on top of streaming data. I've been using Stream Analytics on IoT Edge. I never really used the Edge SQL version of Streaming Analytics or stream processing, because I've just never, I don't know. By the time it came out, I've always been using Stream Analytics, and it's always worked for me, so we just stuck with it. Okay, cognitive services. So cognitive services has two major ways to work on the Edge. And I actually took out the slide for this, and now that I'm talking about it, I feel like I still need to say it, but I took out my slide, so we're going to look at the screen while I talk about it. There are Edge compatible, out of the box, Edge compatible cognitive services containers. There are also containers for cognitive services that are not meant for IoT Edge, but they are already packaged up cognitive services available in a container that you can just use in your Edge solution. Because again, it's containerized, you can just put it on the Edge. I say you can just read the terms and conditions and pricing and all that. What I'm going to show now are the cognitive services that have out-of-the-box built and ready Azure IoT Edge containers, or modules, excuse me. So language understanding can deploy to Azure IoT Edge. So you can create your own Lewis model and deploy that as a container to IoT Edge. You can use the key phrase extraction cognitive services. You can use sentiment analysis. Language detection is a IoT Edge compatible container. Recognize text is, and then finally, or not finally, but there's also facial recognition and identification. So both of those. So you can do facial recognition, is there a face, and you can do identification, is this the face that I was looking for? The newer ones, so that's why they're on a different slide. The newer ones that they've put for Edge are anomaly detector. So if you have a good understanding of cognitive services, you may know about the anomaly detection cognitive service, and that's also available now on IoT Edge. So you can very simply set up anomaly detection in cognitive services on one of your data streams within your Edge devices and pretty easily detect anomalies that way. And now they've also got live video analytics for IoT Edge. So you can use the video analytics cognitive service to classify video streams. So it's basically the computer vision going across the frames of your video as it's getting processed in IoT Edge. And so it's giving you classifications of those frames. What is it? Whatever you're classifying for. I'm actually going to stop for questions because I got to do a naming collision discussion so that when we're done with this talk and you go and you look up stuff, you're not lost at some of Microsoft's naming. So are there any questions that have come up since last time?
Sure. The first one was somebody just actually went and tested CLR in SQL Server Edge, and the CLR enabled function is not even supported. So that would basically include all CLR.
Okay.
And then somebody asked for advice on what functionality should be implemented in the Edge and what would be overkill.
It depends on your solution. What I didn't really have time to go into during this talk is that what I talked about earlier, those Edge tiers. And since sort of Microsoft guidance, and I guess we can also say Amazon starting with this style of branding too, is that if it's not in the cloud, it's the Edge. So you could have a database center sized you could have a data center sized solution that you would need data storage for. And so that's going to be a completely, I don't want to use the word enterprise, that's the only word that comes to mind, but a full featured data solution, virtually everything, replication, all of that would still be considered Edge. For us, when we're talking about devices and gateway tiered Edge solutions, I would say it really comes down to what is your compute capability at those levels. What can the device handle and what can the gateway handle? And then what outside of those, what are the constraints on that solution that would require you to use Edge? So in the case for our cameras, the cameras were actually nowhere near powerful enough to do the image processing that we needed. So we had to really work around that fact as we did the image processing. We did it as a tiered approach. We would have a very, I forget the term because I don't do enough data work, but basically the model that we deployed to the cameras was very happy to say that it saw cars when it didn't see, when there weren't really cars there. So it gave us a lot of false positives. However, it still filtered out large amounts of video data that were still negative for the car. So we didn't need to process it at all. So what we would do is we would take this lightweight model that was a little bit more in the false positives to filter the data that we would stream up and then do the actual analytics in the cloud, so that that had a stronger model that was better able to detect the cars and give us positions of the cars as they went through each frame to give us better traffic analytics. So I don't know if that really answers the question, because I'm going to use the it depends, but it does. It depends on your solution. What are you building? What are your constraints on what actually goes into the edge?
Excellent.
Was that all the questions?
Oh, yeah, that is all the questions.
All right. So now we'll get into the naming collision, and this does affect, for those of you that actually have to do enterprise data solutions with Azure. So we're talking about Azure IoT Edge. So there is something called the Azure Data Box, and some of you may have used it, but the Azure Data Box is something that's used for when you cannot get all of your data to the cloud through an internet connection. Sometimes they need to ship you an actual box, and you need to plug that actual box somewhere into the network and load the data into that box, put that box back on the truck, and the truck goes up to Azure, and they load that data into Azure for you. So that's Azure Data Box. There's an Azure Data Box Gateway, which is meant for a preload, and then after the preload, use it as a gateway to connect from your data center to Azure. And then finally, there's Azure Data Box Edge. So Azure Data Box Edge is Azure Data Box built for Azure's IoT Edge. So the purpose of Azure Data Box Edge is we have, let's say, I don't know, a petabyte of data of just security system footage, and we need to put that into the cloud to process, to create some sort of model. We then take that model and we're going to put it back on our Azure Data Box Edge. And now when we stream our data up to the cloud, we're using the Azure IoT Edge to host our models through DataBox. All right, so that's just to clarify the naming convention. When you go to look for Azure IoT Edge or Azure Edge, you may encounter Azure Data Box Edge, which is related to Azure IoT Edge, but it is just Azure IoT Edge running on the Azure Data Box solutions. One of the things you do get with Data Box Edge that is actually interesting, at least to me, is you can actually get different hardware. What I mean is so for Data Box Edge, it's for the edge compute. It's for you to pre-process the data before you send it up to Azure after you've already done your bulk load, and it lets you run Azure IoT Edge, and then on top of that, these machine learning models at the edge, and it makes transferring that data to Azure easy. There's actually a panel for it in your Azure portal. But one of the things that Azure Data Box Edge actually gives you that I find very interesting is it gives you a different type of silicon that you can run your models on. So we're all very used to the CPU and the GPU as different form factors for running our models. If you use Azure Data Box Edge, it actually uses Intel FPGAs. So the the Microsoft ONNX model that you can export from various different cognitive services, or you can create them yourselves, are compatible with Azure Data Box Edge runtime that has the Intel FPGAs on it. So instead of running it on the CPU or the GPU, you can actually run it on the FPGA. And for anyone that's actually done or looked at some of the stuff from Project Brainwave, it's that, right? You can now take that model and you can run it on the FPGA on the edge. And the marketing says that if the CPU is 1x, the GPU is 10x, the FPGA is 100x. Now, you can also run, and they've broken this down into two categories, into sort of a, this doesn't have to do with Data Box Edge. There's actually for running your models on the edge. They've broken this down into two categories, I think now, but you can really think of it as an ASIC as a custom silicon. So if you think of like TensorFlow's, the name escapes me. You could basically get the time from Google Cloud Compute to run the TensorFlow models on specific silicon built for running TensorFlow models. But the name escapes me at the moment. But that would be an ASIC. It is a custom built circuit specifically for running the model. And so now they've gone for basically a soft and a permanent and non-permanent ASICs. So some ASICs you can program and change its configuration, but it's still custom built for certain models. And then there are permanent ASICs, which is almost a circuit board printed specifically for a model that you built. Okay, so what did we talk about? We discovered edge computing, talked about Azure's IoT Edge, discussed the edge components, went over some cognitive services, and then we looked at, like, if all this comes together, what can we do? All right. Are there any final questions?
All right. Waiting for final questions to come in because we've kind of covered all the ones that have come in so far. So thank you, Jared, for the presentation today. If anyone does have any questions, now's a great time to type any additional questions. Now's a great time to type those in. And it appears we may have answered everyone's questions throughout. Oh, here we go. Was there a diagram at all to see how all of these fit together?
There are. I didn't put any in the slide deck.
Okay. I'm sure in the documentation, folks can dig that out.
There's a specific one for Azure IoT Edge where you can sort of see them all fitting together.
Okay.
Yeah, so there would be one there if you wanted to see one of them. And when you say all, you'll get an architecture diagram if you go to Architecture Center, which will show you sort of how to build some solutions, how to architect them with these components fitting together. But there's so many components now and so many third parties that you won't ever see, all at once. Excellent.
Well, that appears to be all the questions then for today. So Jared, thank you for presenting today. This has been a great session. I've been wanting to learn more about all of these pieces, so this has been pretty great for myself. Hopefully it's just as informative for everyone that was on the webcast today. So thank you.
Thanks for having me. Hope you guys learned something.
Excellent. And everyone have a great rest of your day. And goodbye.